Welcome back. We are now at creating a VIT feature extractor. In the last video, we collected some of the stats for our EfficientNet B2 model. So now let's do the exact same with a VIT feature extractor. And I issued you the challenge of giving it a shot yourself to go through the same steps we've done with FNet B2 as with a VIT feature extractor. So I trust you gave it a shot, but let's now do it together. So the model we're going to use, if we go to PyTorch models, or Torch Vision models, we're going to use the same one that we used if we search for vision transformers. Here we go. The same one that we used in the previous module, but it should work for any transformer variant you want to use. Just beware that the larger, so this is VIT base 16, VIT B 16, this is VIT B 32, VIT large, and this is VIT huge. So base, smallest version, large, intermediate, huge, biggest model. So as you start to increase the size of the model, it decreases our chances of being able to deploy it to a device. So if we have number of parameters here is 86 million for VIT base, and then if we go into VIT huge, we see better results, but we have 633 million parameters instead of 86 million. Just something to keep in mind. So let's go ahead with VIT base. I'm going to copy this into here. So we want this one. So we can go, let's check out the heads layer, because what we want to do is turn it into a feature extractor. And unlike the FNet B2 model, where the head layer was called classifier, VIT's head layer is called what? Well, let's find out. Check out the vision transformer heads layer. Because what are we trying to do? We're trying to customize a pre-trained model to our own problem, and one way to do that is to adjust the output layers. VIT heads, wonderful. So let's keep going. If we wanted to have a look at all the layers, we've got all those layers there. We saw this in, if we go back here, we saw this in PyTorch paper replicating in these sections here. But let's keep pushing forward. We're going to create a function to create a VIT model. So very similar to our create FNet B2 model, we're going to adjust this to work for create VIT model. So let's go def create VIT model, and then we'll set number of classes equal to an integer equals 3, and then we'll set the seed by default to be 42. Then we're going to create a VIT base patch size of 16 pre-trained weights, and we want the transforms, of course. So if we're going to use a pre-trained model, we want to pass it our own samples formatted in the same way that that pre-trained model has been trained on. So let's go weights equals torchvision.models.vitb16 weights. And I'm going to get the default. Recall that .default stands for best available in PyTorch. So transforms is weights.transforms. This is going to be the transforms, the data transforms associated with these pre-trained weights. Finally, we can set up the model to be torchvision.models vitb16, and we'll pass in weights equals weights. So that's just the weights from above. Very similar function to what we did before with FNet B2. So now we're going to freeze all of the base layers, keep those pre-learned patterns the same in model.parameters, because we want to make a feature extractor. Fine tuning, if we wanted to fine tune this model, we might leave some of the layers unfrozen so that they can adapt to our own custom data. Fine tuning usually works best when you have a much bigger data set. So let's change the classifier head to suit our needs. So this is going to be this layer here in case of the vision transformer. We want to change that to suit our problem. So I'm going to set the manual seed here for as reproducible results as possible. And I'm going to go model.heads equals nn.sequential, nn.linear. Then I'm going to pass in features equals 768, which is in line with this here. And then the out features is going to be what? Out features is going to be our number of classes. Beautiful. So that's going to adjust it to our particular use case. Finally, we can return the model and the transforms. So let's test our function out, hey? I'll go vit and vit transforms equals create vit model. And we can just set that as default. So now let's have a look at vit. We'll look at the vit transforms, and then we'll look at the model summary. So it's going to download that from PyTorch. Download all the pre-trained weights. Oh, what's going on here? Froms. I got it spelt wrong. Wonderful. So we have a slightly different image size for our vit model. That could be something that we could adjust to make sure that both of our models take in the same input size. But for now, we're just going to leave it how it is. The mean and standard deviation are very similar to our FNet B2. In fact, they might actually be the exact same. Yeah, there we go. This is because both of the architectures, Vision Transformer and FNet B2, are pre-trained on ImageNet. And so let's get a summary. I'll just come up and copy the summary code that we have here, but we'll sub out FNet B2 and we'll put in our vit model just to make sure. Print vit model summary, and we'll put vit in there. We'll change the input size to be 224, 224. We don't necessarily have to, but we'll see how it goes. Boom, there we go, look at that. So our Vision Transformer has a Conv2D layer that's going to patchify our images. We saw that in the last section, PyTorch paper replicating. And then it's got a stack of encoder layers before it goes out to the output layer here. And you'll notice what we've done is we've frozen all the base layers, and the output layer, the heads, is the only layer that's trainable. So we have 85,800,963 total parameters, but only 2,300 or thereabouts of those are trainable. So with that being said, what do we have to do next? We've got a model. Well, it's time to create some data loaders. So let's do that in the next video. 4.1, create data loaders for vit feature extractor. Now, you might want to go ahead and give this a shot yourself. We've done something very similar for FNet B2. The code is going to be virtually the same, except we're going to be focused on the vit feature extractor. So give that a go, and I'll see you in the next video.